Let's see one question from the homework. Homework question. Let's see here. We're looking for. Let's see one example on your 4.1, question number 10. Okay, this one. Let's see, question 10. It's not very hard, but sometimes it's very tricky when you are plotting the point. Let's practice a new question. So if we have h of x equals negative e to the x, we must know that the function, okay, let's move to here. Okay, the function f of x e to the x, f of x equals e to the x. We're having the graph like this. This is an increasing function because the e is greater than 1. So it will pass through the key point 0, 1. And how about h of x? H of x equals e to the negative x. The changing is all the x becomes negative. So that's the reflection along the y-axis. You can put some marks here. And all the x multiplied by negative 1. So let's see the function. Let's see the example here. How to graph the h of x. First, I can select the exponential function and then click the solid line here. And then I will plot the key points here. Then it shows us the transformation steps. Is there any vertically stretching or shrinking or horizontal stretching or shrinking? No. So we'll leave them blank. If there is, you put some information here. Vertical translation? No. Vertical translation or horizontal translation means move up or down or horizontally shifting. So nothing. If there is shifting, you can move the cubes here. No cube. This is square. So if there's no, we just stay as keep them stay at 0. Is there any reflection about the y-axis? Yes, all the x becomes negative. We selected this, and the base is e. Then next step, I will click the exponential 2 again, make it into the blue. If now you save it and submit it, it will give you the wrong solution. What is the next? I need to graph the horizontal asymptotes. So click the dash line and click the line 2. I know that horizontal asymptotes is y equals 0, but I know that 2 points can decide the horizontal line. I can click here and then click here again. But right now it's a yellow curve. So I need to click the line 2 again, make it into the blue. Now I click save and click check answer. Where is my, oh, I see. This is one is a different one because I'm thinking is the h of x equals e to the negative x. It's not e to the negative x. It's negative e to the x. Oh, they change the question all the time. So let's erase this because the new h of x changed. That's negative e to the x. Okay, so if you have e to the negative x, you can draw like that, but they change the question. All right, negative e to the x. Now I'm not reflecting my graph along the y-axis because in front of the e, we have the negative sign. That's reflection along the x-axis. So all the y's value multiplied by -1. That's an interesting one. So I must decide the new key points now. So before we have f of x, the key point is 0, 1. Now we have h of x. x didn't change, and all the y's value might multiply by -1. So 1 times -1 is -1. So we have the key point 0, -1. All right, read the question. Be careful because it changed the example all the time. So let's see. Now let's clear the graph. Let's clear the graph. And then I still select exponential 2 and solid line. And then I will click 0, 1, because this is the key point for the f of x. And then is there any reflection? Yes, reflection about the x-axis. The base is e. Yes, it is. And then I will click blue, line 2. Oh, sorry, not line 2. The exponential 2, make it into blue. And next one, I will click the dash line. Then click line 2 to decide the horizontal asymptotes. I just click 2 points here. That's a yellow dash line, and click the line 2 again, make it into blue, and then click save. Now let's check the answer. Yes. So be careful. The question is h of x equals -e to the x. It's not the same one because I prepared my question with a different function, e to the -x. All right. What's the next question? Find the equation of the asymptotes for the h of x equals -e to the x. From the graph, you will see we are having the horizontal asymptotes. Y equals 0. So you put y equals 0 and check your solution. And observe the graph and find the domain. So can you find the domain of this exponential function? All real numbers. So let's put -infinity to infinity. Delete that. So check the answer. How about find the range? The range is from 0 to -infinity, or sorry, -infinity goes first. -infinity, comma, 0, and all of them we're using parentheses because we cannot have 0 brackets. 0 is asymptotes. The graph never touch it. All right, check my answer. Yes, we made it. So next example, you see what is the transformation? 1/2 times e to the x. That's the vertically compress or vertically shrink. All the y's value multiplied by 1/12. So the new key point changed. But at the beginning, when you graph it, you don't need to say you don't need to plot the new key point. You just select this and then click here. The base is E, and vertically stretching or shrinking. Yes, shrinking 1 divided by 12. Let's see. Yes. And then click the exponential 2 again, make it into blue, and we need a horizontal asymptotes. We can pick 2 points. Yes. And then we save. Hopefully no mistake. Yes. And then you need to what is the asymptotes? Y equals 0. You follow the same method we have mentioned in question 10. All right, let's go back to see our example. Compound interest. Compound interest, we will use it. Let me clear the area here. We will use this when we are borrowing money or deposit money into the bank or some other cases. We will use this. So let's see, what is a compound interest? For example, if I use P represent the initial amount or principal. If I have $100 and then I go to the bank said, if you deposit $100 into the bank, I will give you the interest rate per year is 1%. So after a year, how much money you will get from the money? From the bank. So I will use A represent the final amount or future value. So first I need to get $100 back. And also based on my $100, the bank will pay for the interest. The interest is P times R. So this is the future value. And then I plug in the P's value and the R's value in this formula. And now I say I can pull out the P because both of the term has the P. So I pull out the P. I have 1 plus R. This is the money after a year. How about the second year? So the bank said, if you continue to deposit money, I give you the same rate. And then after a year, you get your principal back, you get your initial money back, and also you get the interest. So the second year, you continue to deposit money, but now you have the new amount of the initial because you get more money from the bank. So the new initial, so I can say this is my first year future value. And second year, so the new money you deposit is A1. And then based on the A1, you multiply by the rate. Then you plug in the A1. That's P times 1 plus R. And then plus A1 P times 1 plus R. Then times R. Now, both of them, they have the common factor GCF, P times 1 plus R. I can pull out 1 P times 1 plus R. The leftover is 1 plus R. We have 1 plus R times 1 plus R. That's P times 1 plus R squared. Then in the third year, A3, if I simplify my procedure, I'm having P times 1 plus R times 3. The fourth year, the power becomes 4. So we are getting a formula in the T year. The future value A equals principal or the initial amount of money times 1 plus R to the T's power. So we're having the formula. We follow the formula, we can know the future value, or we say the final amount. This is the formula for growth. And how about the formula? Okay, formula for decay, because you're not always getting money. Sometimes you lose your money. For example, you buy your car from a dealership, and every year you lose the money because the value will decrease. So we are using this formula, A equals P times 1 minus R to the T's power. The A is final amount, P is initial amount, R is the rate, T is time in years. Be careful, T is time in years. If in the example, they say we have the T equals 24 months. So when we are plugging in the formula, we are not plugging in 24. We must plug in T equals 2 because 1 year has 12 months. 24 months means 2 years. All right, let's see one example using the formulas. The starting salary of new employee at the Thrifty Federal Credit Union is $35,000. The salary increases by 3% each year. What will be the employee's salary after 10 years? Let's identify what is the A, P, R, and T. There is no A because I'm looking for the A. That's the final amount or future value. The P is the initial amount or or principal. That's 35,000. And what is the 3%? That's an interest rate. So R is 3%. We can convert it to the decimals. That's 0.03. How did I change it? Because I moved the decimal point from here to the right, to the left, two decimal places, 1, 2, and then ignore the decimal percentage sign. All right, let's see, what is the other information? 10 years, that's a T equals 10 years. The unit is years, so we don't need to convert it to the years. So it's asking for the, I'm losing the first one because your salary, the employee's salary is increasing. So we use formula for growth. That's a P times 1 plus R to the T's power. So plug in all the information. So P is 35,000 multiplied by 1 plus R is 0.03 to the 10 years. So we are using the calculator. It's here. Okay, that's 35000. Yeah, 3 zeros, and then parentheses. Even I don't have multiply sign, but if I have parentheses, that means multiply by the parentheses 1 plus 0. So where is the, oh, sorry, move it here. I want to move it a little bit up. It's too tiny. Okay. So here is the decimal point. Look at here. 0.03. Close the parentheses. Click caret sign or exponent sign here between clear and the division line. So click here. We put 10 there. Move the cursor. Hit enter. So we must have the amount of money like this. So let me copy down. Let me memorize this. I can't memorize them. 4, 7, I think, comma, 0, 3, 7.0 something. Really bad memory. 7328. 7328. We need to round it to the 2 decimal places, right? Because round to the nearest penny, that means we need to keep only 2 decimal places. The digit after 7 is 3, is less than 5, so I can ignore them. So the money is 47,037.07. All right, we finished this one. Let's see number B. Number B, a car originally priced 35,000 and it loses 15% of its value each year. What is the value of the car in 3 years? Round to the nearest penny. So let's identify the information. This is the initial amount or initial principal. That's the P. 35,000. What is the 15%? That's a rate for the decay. That's 15%. Converted to the decimals. We move the digital point to the left, 2 units. Okay. So if I'm moving it to this, I'm having 0.15. How about next information? 3 years. That's a T. That's a 3. Which formula I'm using? The decay one. P times 1 minus R to the T. So we have 35,000 multiplied by 1 minus 0.15 to the T 3. Let's use calculator. Move it another side. come back. All right, let's put 35000 multiplied by 1 minus 0.15. Close the parentheses, click caret sign, or click the exponential sign, put 3. Move the cursor to the regular position, hit enter. So we are having 21494, 21494, 21494. Oh, it's not disappearing, so I can keep them on my screen. 375, but we need to keep nearest penny. I need to keep these 2 digits, but the digit after 7 is 5, is greater than or equal to 5. So the 7 plus 1, we have 21414.38. Okay, you see the price of the car decreased because you lose the value each year. All right, let's see next part. Minimize the calculator. How to make it big. Okay. All right, comes back. So formula on the previous page is designed for annual compounding, but more often you compound the faster your investment will grow. The following formula follows for additional compounding with a year's time. Okay, sometimes we are not compounding annually. The bank say, I can provide you compound semi-annually or compound quarterly, compound monthly. So you will get more interest after a year or after several years if you compound multiple times a year. So we are using the new formula. The future value A equals P, initial amount multiplied by 1 plus R divided by N, all of them raised to the N times T power, where the N is the number of compounds with a year T is the rate and the T time in years. What's the meaning of that? So if the N equals 1, that means we compound annually. That means we compound once a year. If N equals 2, we compound semi-annually. That means we compound twice a year. If N equals 4, we compound quarterly. So we compound 4 times a year. If N equals 12, we compound monthly. So we compound 12 times a year. Okay, come back. So we are using this formula to find the future value. And also, we will learn the compound continuously. What if you want your investment to compound trillions of times per second? We are using the base E, the special number E. We have a formula for computing continuous compounding interest that use E. A equals P times E to the RT. R is the rate and T is time in years. We are not using this formula. We are using the new formula for the continuous compounding. Let's see number 53. Find the accumulated value of an investment of 10,000 for 5 years at an interest rate of 5.5% if the money is compounded semi-annually, quarterly, compound monthly, or last one is compounded continuously. First 3 we are using the formula here, but the last one we are using the formula here, A equals P times E to the RT. All right, let's identify the P. R and T. So the P is initial amount, that's principal 10,000. And how about years? Years, that's T. T is always in years. In previous formula, the compound annually, the T also means years. You cannot make months, several months in the T part. And the rate is 5.5%. And I can equal sign. I can convert it to the decimal, move the decimal point to the left 2 units, 0.055. So number 8, annually. Semi-annually means N equals A equals T times 1 plus R over N to the NT's power. So plug in the P, R, N's and T's value. Oh, sorry, click the wrong button. The P is 10,000 and 1 plus R over N. R is 0.055 over N. N is 2 because compound twice a year. N is 2 times T is 2 times 5. So we are using the calculator. I hope I have enough space. So calculator, run the calculator and put 10,000. Yes, 10,000. And then put all the information in the parentheses. 1 plus 0.055 divided by N. N is 2. Raise it to the 10th power. So we click caret. 2 times 5 is 10. You can also put 2 times 5 there. It doesn't matter. And then move the cursor to the regular position, hit enter. I hope the calculator stays there so I can copy the information. That's it's disappeared. How to make it come back? 116, I remember that. 0.51033. All right. So we need to keep 2 decimal places. So I'm keeping these 2. Because the digit after the 1 is 0 is less than 5. So ignore this. We have 13116.51. And you can put a comma here. So number B, what is the N compound quarterly? Quarterly means you compound 4 times a year. So A is 4. And the A, we use the formula, so I can directly plug in the PRNT's value. P is 10,000 times 1 plus the R is still 0.055. Oh no. And 5 over 4 because now N is 4. N times T is 4 times 5. Let's plug in the formula. That's 10,000 multiplied by 1 plus 0.55 divided by 4, and then raise it to the 4 times 5. You can put 20. You can also put 4 times 5. Click the cursor, move the cursor, hit enter. 131530. 131530. 131530 point what? 9953. All right, keep 2 decimal places. Am I correct? Let me check. So the answer is a little bit different from my. Oh, I see. My cheat sheet doesn't have this. Let's see. Where is the mistake? I'm sorry. Okay, where is the mistake? It's here. The rate is 0.055. So I can modify my input. So we can insert a 0 here. So click second and DEL, second delete, second DEL. I'm adding something. Did I? So put 0 here. Yes, I put the 0 there. Come back. Okay, move the cursor. And now let's check if I have no mistake. Yes. Hit enter. Yes. This time we are having the correct data. So let's put the data here. Okay. Erase the old data and put the new data here. That's 1314.0.1. 66502. 66502. We keep 2 decimal places. Let's look at the third digit. That's 5. Is greater than or equal to 5. So we need to add 1 at the 6. So we have 13140.67. Number C. N equals compound monthly, N equals 12. So A equals 10,000 multiplied by 1 plus 0.55 over 12 multiplied by 12 times 5 because N times T. Okay, let's use calculator. Right here. Come back. Don't make a mistake this time. So 10,000 times 1 plus 0.055 divided by 12. Close the parentheses. Raise it to the 12 times 5. 12 times 5. Move the cursor. All right. We have 13157.03773. I hope this time I have no mistake. Do I have any mistake somewhere? There's no mistake. So let's put the solution here. Yeah, I'm so glad the calculator is still here. It's 13157.03773 and round it to the penny. So keep these 2 decimal places, and 7 is greater than 5. So we make the 3 add 1. So we have 13157.04. All right, what's the last question? So keep the computer here, calculator here. Last question, compound continuously. We are using different formula. So if we are using different formula, we have future value, put D here. Future value, where is the, yes. Okay. So future value A equals P times E to the RT, and the P is 10,000 times E to the R. R is 0.055, and the T, what is the T? I think it's 5 years, right? Yes, 5. T is 5, and then put them into the calculator. So let's clear the screen. 1,0,0,0,0. 10,000 multiplied by E. Where is the E? You click second, and then you see ln. Okay, click ln, and then put the power there. 0.055 multiplied by 5. Move the cursor, hit enter. So we are having 13165.30675. We need to keep 2 decimal places. So here is 6. That means we add 1 to the 0 part. We have 13165.31. All right. Make it bigger. All right, you see, we found all the future value for different compounding. And you see, if the n is 2, use different color. If n is 2, we are having this amount of money. If we have 4, we have this amount of money. You see, the money is increasing, right? Yeah, and if the n is 12, we have the money is increasing more. If we have compound continuously, we have most money. That means more times, or if we compound more often in a year, we get more future value. It's good for the people who deposit money. They have multiple times compounding a year. But if you own the money from the bank, you borrow the money from the bank, they said, I will charge you, I will do the compound monthly or by daily. You will lose your money very tremendously, because you give them more interest, and you pay them more money. So communicate with your bank if you own money from the bank. So discuss what is your compounding. How many time you need to, they said, compound a year. If they compound continuously, well, you lose money a lot, but you can pay quickly, so you don't need to pay a lot of money. Because you see the formula here, if the t here, you have less time, you have maybe 0.5 there, you don't need to pay a lot of money in the future. But if you have to pay 40 years, you will pay them a lot. All right, that's about 4.1. If you have any question, please let me know. Have a good day. Bye-bye.